today we will discuss on chemical bonding. So in this lesson, we will discuss the 4 learning objectives. The first one is the definition. What does chemical bonding mean? And the reason for the bonding. Why does atom bond with another atom? So to explain this, we'll talk about octet rule. And after that, we'll look at the types of bonds. And we will discuss the activities. So now, the definition of chemical bonding. So what does chemical bond mean? So it says it is the combination of 2 or more atoms. When 2 or more atoms combine together, that is called chemical bonding. So how does it happen? How does chemical bonding occurs? So it occurs by sharing of electrons or transferring of electrons. So atoms, they combine together either by sharing or transferring of electrons. Now when we say transferring of electrons, we need to keep in mind that there is losing of electron and gaining of electron. So whenever you hear the word transfer of electron, just remember that it means losing and gaining of electrons. So when they share or transfer the electrons, what happens is there is rearrangement of the valence electron in the outermost shell. So when atom combines together, they either share or transfer electron, and during that time, the valence electrons get rearranged. For what reason do they rearrange their valence electron? Is to become stable. So to become stable, they rearrange their valence electron. So how do we know that they are stable? So there's a rule that's called octet rule, and we all know that octet stands for 8. So if the atom have 8 valence electron, or you can also say 8 electrons in their outermost shell, then the atom is said to be stable. So once again, atom to become stable, to acquire 8 electrons in the valence shell, they combine by sharing or transferring of electrons. And that is what we call it chemical bonding. Now when we talk about rule, there is one octet rule, and there is also another rule called doublet rule. Now the word doublet stands for 2. There are some atoms which, when they have 2 valence electron, they tend to become stable. Just like helium atom. If we have to write the electronic configuration of helium atom, it's just 2. So likewise, we have hydrogen and then lithium, which also need to acquire 2 valence electron, then they are said to be stable. And now let us try to look at some example to understand the chemical bonding and how does the atom become stable through octet and doublet rule. So let us consider the first example, that is H2, hydrogen molecule. So first, let me write its electronic configuration. Since we know the atomic number of hydrogen is 1, the electronic configuration is only 1. We already learned about the doublet rule, which says hydrogen need to acquire 2 electrons, 2 valence electrons to become stable. So hydrogen need to gain 1 more electron to become stable. Since there are 2 hydrogen atoms, let me just represent it with this. Let us say it is the hydrogen nucleus. and the circle that I've drawn is the hydrogen's valence shell, and a dot to represent its one electron. Now, this is only one hydrogen atom, so let me just draw another hydrogen atom. So what I'm doing here is I'm drawing a valence shell which is overlapping with the another hydrogen's atom. So this is the dot here represents the electron of the hydrogen. So if you look carefully, the shell has been overlapped, and that indicates they are sharing electrons. So now let me just count the number of electrons present in the first hydrogen. So 1, 2, 2. Now let me count the electron present in the second hydrogen. 1, 2. So what has happened here is both of the hydrogen atom, they got 2 valence electron. Here also they got 2 valence electron. So this is what we call duplet rule. So once again, the 2 hydrogen atom, they have combined together by sharing electron and through rearrangement of their valence electron to become stable. Now the second example we'll look at it is water molecule. Water molecule. Here we have 2 elements, hydrogen and oxygen. So we know hydrogen's atomic number is 1, oxygen's atomic number is 8. Now let us write the electronic configuration. So for hydrogen it is 1, for oxygen it is 2, 6. So first shell contains 2 electrons, second shell contains 6. And the 6 is the valence electron of hydrogen, valence electron of oxygen. Now let us look at it. Hydrogen, we already know it will follow duplet rule to become stable, whereas oxygen will follow octet rule. It has 6 valence electron. Now to become stable, it needs to gain 2 more electrons. Then it will acquire 8 valence electron, and it is said to be stable. So let me draw the atomic structure for our oxygen atom. The blue colored, this O represents the oxygen nucleus, which is enclosed here. Now let me draw the first shell of oxygen atom, contain 2 electrons. Then the second shell, which contains 6 electrons. So 1, 2, 3, 4, 5, and then 6. So the dot that I have drawn here represents the number of electrons. So the valence electron contains 6. Now to become stable, it needs to gain 2 electrons. So from where will it gain 2 electrons is from the hydrogen atom. We will get 2 electrons from the hydrogen, 2 hydrogen atom each. So let me just draw the hydrogen here, enclosed in its nucleus. Now to gain hydrogen, to gain duplet state, it needs to share its 1 valence electron with the oxygen, and in return oxygen will also share its 1 electron with hydrogen. So for this I will overlap. Here I have represented the dot as the hydrogen's electron. So let me just draw another hydrogen atom. So another hydrogen atom will also share its 1 electron with the oxygen atom. So this blue represents the electron of another hydrogen atom. So if you look closely, what you will find is this hydrogen atom, it has already acquired 2 electrons in its shell. So this blue represents the electron of another hydrogen atom. So if you look closely, what you will find is this hydrogen atom, it has already acquired 2 electrons in its shell, hence becoming stable with diplet state. And also the another hydrogen atom also acquired 2 electrons in its shell, hence it also became stable. And regarding the oxygen atom, if you count the electrons of oxygen atom, so 1, 2, 3, 4, okay, count the oxygen atom, 1, 2, 3, 4, 5, 6, 7, and 8. So that means oxygen also became stable and it has followed octet rule.